Hello everyone. In this video, we are going to see how we can handle shadow DOMs using CITS. Now, shadow DOMs are pretty interesting in the field of test automation because in browser automation, Selenium is not very easily able to handle shadow DOMs. So, what exactly is a shadow DOM? It is actually the embedding of DOM elements into a web page, but not directly making those web elements be part of the main DOM document. Let us see this with an example. In this application, there are um, four elements. The last one, the scroll.html, is not associated with the shadow DOM, but the top three are. So if we right click and do an inspect, and if we try to inspect the first one, see this some text, the first one is inside a shadow root, right? So what essentially it does is it is embedding the DOM element, the span and the span inside it, but is not making it part of the main HTML, the main document. And therefore, Selenium cannot penetrate through this shadow root or the shadow elements and identify this element with XPath ID or whatever identifiers. The only tool in my experience which seamlessly handles shadow DOM or shadow elements are or is Playwright. But with Kits, we'll try to see how we can do this rather seamlessly as well, because Kits also uses Selenium in the backend. Now, if I show you the next element, the nested text, this also is under a shadow root, right? Now this is a nested shadow root. So this shadow root is falling under the main shadow root. See, this shadow root is falling under the main shadow root. So this is even more complex because in modern projects, in big projects, in complex applications, you will have lots of nested shadow roots, and thereby piercing these shadow roots and finding the target element becomes extremely or exceedingly difficult. But if I look at the last element, scroll.html, now this is not inside any shadow root, and it is directly associated with the main HTML. So it's rather simple to handle this. Okay. Now, if we have to do this using Selenium, vanilla Selenium, then what would we do? There are two ways of handling this. One is, so if I want the first one, some text to be identified, then I have to identify this shadow root, which is its parent shadow root. And then once it is identified, uh, then I would be able to use CSS selector to identify the span underneath, and that would work. Um, for the next one, the nested text, if I am able to identify the first shadow root, then I can use the CSS selector to identify its next shadow root, okay, the child shadow root, and then again a CSS selector to identify the div underneath. So the problem with this kind of an approach is if there are multiple nested shadow roots, you would every time have to find the first shadow root and then use CSS for the next one, and then for the next one, and then for the next one. So there's a continuous looping of identification across these shadow roots. Now, to understand this a little better, let's use Selectors Hub. Now, Selectors Hub is basically a Chrome plugin with which you can easily identify XPaths or CSS. So I already have the Selectors Hub installed. So in order to identify how we can handle this using Selenium, we're going to look at the nested text. Yeah, and then if I go to Selectors Hub, You see, the alert already says that this element is inside the shadow DOM, which cannot be accessed through XPath. Okay, now here it also gives us an example of how you can handle this using Selenium. So if I'm going to copy this and come to Notepad++, let me expand this a little bit. So it says that this is inside two nested shadow DOMs. Okay, the first one is shadow host. So let's go back and check, which is this, the shadow host with the div ID of shadow host, which is correct, and then the div ID of nested shadow host. So the div ID of nested shadow host. Now to handle this, we are going to have to first use find element by CSS and then the first one to get the first shadow root, and then using this element which is shadow 0, we have to find again using CSS the nested shadow root, which is the next shadow root, using the get shadow root function. Now get shadow root is a function which is only available in Selenium 4 and is not available in the previous version of Selenium. And then once you have the nested shadow root, then you can again use CSS selector to find the text that we are looking for, or the element that we are looking for. Now for me this is a rather complex solution because, as I explained, if there are multiple nested shadow roots, this is very cumbersome to keep creating these search contexts one after the other, and then finding the elements one after the other. One very quick and easy solution to try out is the use of JS path or JavaScript path. Now, if I simply right click on this element, which is my nested text element, right click and copy, and then copy JS path, okay, and I bring it here. If I look at this JS path, it actually tells me what is happening. So it says query selector, document.query selector, and then the ID of the first shadow root. Then it says dot shadow root, again the query selector, and then the second shadow root, and then again the query selector, and then the final element. So a JS path already is a very strong identifier for this element. A JS path in totality does not require any looping because it is already chained, right? And the way to find the JS path is very simple. Right click, copy, and go and copy the JS path. Now, if you want to use selectors hub also, that is also fine, because in selectors hub, you also have JS path that you can directly use, right? You can copy it using this copy icon. So if I have a JS path of an element in a shadow root or not in a shadow root, I can identify this element on the screen pretty seamlessly. Now let's see how we can use this JS path in CITS and identify this element like a normal element and not discriminate it like whether it's a shadow root element or not a shadow root element. Now in CITS, if we look at an object in the object repository, for example, this one, um, the identifiers are name, ID, link text, relative XPath, XPath class, CSS type mostly, right? So there is no JS path that we just spoke about, right? So that is an attribute that we have to create. So this is an attribute that we have to create, and then we have to ask the tool to use that attribute while it is interacting with the website. It's as simple as that. Now, how are we going to do this? So very quickly, let's create a scenario, and we're going to name it Shadow Dome, and then a test case underneath. Let's call it TC1, and then the first step would be to open the browser, and the browser is this one. This is the application that we are going to use for our testing. So this is done. Then, uh, then what are we going to do in this application? The things that we are going to do are clicking on some text. Maybe we're going to highlight every element, yeah, or maybe we can also add some text to this box, right? So let's do that. So um, we're going to create a new page. Okay, so in the object repository, we're going to create a new page. We call it add page, and we're going to say um, shadow DOM. Yeah, then we're going to create, let's see, one, two, three, four, five objects. Yeah, the five text that we see, and then the text box. Okay, so Control N is a shortcut, so Control N, one, two, three, four, five. Yeah, five objects created. The first one is some text, right? So we're going to name it some text. Second one is nested text. Nested text. Let's write it in the exact same way as it is appearing on the screen. Good for reference. Then we have scroll.html as one. So scroll.html one. Next one would be scroll.html 2, and the final one would be this text box, and we're just going to call it text box. Okay, so five elements have been created, but we haven't used the identifiers for them as of yet, right? So I'm going to drag and drop all of these to create a test case. So now, as I was saying, let's use highlight as an action. We can do anything, right? We can use click, store text, whatever. But I'm going to use highlight as an action. And in the text box, I'm going to set some data. So I'm going to say set, and let's say I'm going to set dummy. Okay. Then I'm going to use browser pause. This is just a dummy line that I use usually in order to put a breakpoint so that I can run the test case in a debug mode. And I'm also going to put a breakpoint at line number 2. Yeah. So the test case basically looks like this, but hang on, we haven't added anything to these elements yet, right? So the first element, some text. So what we will do is, as I was saying, we're going to need the JS path as an attribute. So by clicking on this plus icon, we can create an attribute of our own. So you see, new prop comes in. We're going to name it as JS path. Okay. Now JS path for some text is, so if I go and do an inspect, and do a right click copy, and I go and copy the JS path. I come here and paste it. My JS path is set. Okay, so that's some text done. Then the nested text. Nested text. This is the div. Right click, copy JS path, and I need to add the new prop JS path, and then paste the value. Yeah, remember the JS path, as I already explained, has the shadow root or the nested shadow roots chained in its own value, so we don't have to worry about anything. It's just simply copying the JS path and putting it in the value of the attribute, right? So scroll.html. So for this one, this also comes inside a shadow root. So this basically comes inside this shadow root. So if I do a copy and JS path and add JS path here, JS path, and put the value, you see it tells us that it is also inside the main shadow root, which is the hash shadow host, and then the shadow root. Okay, and then we have the last one, which is scroll.html. Now this one is not coming inside any shadow root. Okay, if I collapse this shadow root, you see this is not coming inside any shadow root. It is in the same level as the shadow root. Uh, so we have two options. So either we copy the JS path also for this kind of an element, that is also fine, or we just simply write an XPath. So I'm going to just simply write an XPath and I'm going to say A, because this is the only anchor in the main HTML body, and that's it. So I'm going to use this XPath for this element and this text box. So let's see this text box. This is the input type. It comes under the main shadow root. So let's also use this copy JS path, and we're going to say JS path and then the value. Okay, so we are done with adding a new attribute for these objects called JS path, and then also fitting the corresponding values of these JS paths. Okay, now ideally, a JS path is, since it's a new attribute, we also need to tell the tool that, hey, listen, we do not need you to pick up the attributes from these values. We need you to pick up the attributes from JS path. Okay, so we're going to tweak the engine. We're going to enhance the engine in such a way, and it's going to be a one-time activity, of course. We're going to enhance it in such a way that going forward, if you just simply add the JS paths, it will always pick up the JS path and then interact with your element the same way as it would for any other HTML element. Okay, so how are we going to enhance this? So we go to the engine. Okay, if you have not seen my video of how to write your custom code, please do visit that, because that is very, very important for you to understand what I am doing here. Okay, I'm going to put the link of that video in the description section. Please go and check it out if you haven't. Okay, now in order to enhance this, we would be using this package source, under source main Java. We have um, like a package called engine.drivers. Under engine.drivers, we have something called automation object. Now, this is the class where we are able to identify all the objects. So if I scroll down a little, it's quite a lot of code, but this is the method, right? With the return type of list, the type of web element. This is the method get elements, which we need to enhance. Now this get elements, essentially, if you look at the code, is actually reading the OR attribute one after the other. So it is reading this object repository, OR object repository attribute, one after the other. So it is a loop, a for loop, one after the other, and is returning the value as return elements. Okay, that's how this method basically works. So I'm not going to go too much in details of this method, but what I would do is, since I have added a JS path as a new attribute, I would just add some lines of code here in order to ensure that the tool understands that, hey, we have a new attribute that we need to take care of. Okay, so how are we going to do this? We're going to simply say So if you see tag, now tag is the attribute dot get name and value is the attribute dot get value, right? So this is the name of the attribute and this is the value. Okay, so I'm going to add an if condition before the return statement. So I'm going to copy this and I'm going to add an if condition here. So I'm going to create a demarcation first because this is where my code is going to be. Okay, and now I'm just going to paste this. So if tag dot equals JS path, right? Because that is what we have done, JS path. If tag dot equals JS path, and we are going to also try to get the value, right? So here we are going to say if um, attribute dot get value. I would add a trim as well. Dot is empty. So I'm going to check if it is not empty. Only then I'm going to work with it because it may so happen that you add the JS path and then you don't do anything with it, right? So there is nothing that is filled in. That's also okay. In that case, we have to simply ignore JS path and move forward with these attributes. But so that is why I'm going to use this additional if condition. And I'm going to say only if it is not empty, then I'm going to use JavaScript executor. JavaScript executor JS equal to, then I have to cast the driver as JavaScript executor. And the driver. So this driver is already exposed by CITS to us. So this is the web driver which you can use. Now I've explained about this also in the video where I explain about custom functions. So please do have a look at that video to understand this. So now I have what I'm saying is my driver is going to be a JavaScript executor type. Now what I can do is I'm going to simply use this driver to find the elements using JS path. So I'm not going to say driver.find element by say XPath, CSS, or ID, but I'm going to find it using JS path. Now, before I do that, we have to return it to elements, right? So because elements is the is the web element list that is being returned by this method get elements. So we have to return it to elements. Now elements has been initialized as null, so we basically need to simply create an instance of this class. So instance of this object. So elements is equal to new array list of web element. That's it. That's all that we need to do. So now elements, a new instance of elements has been created. Now in this elements, we need to add the element that we are going to find using this JavaScript executor. So elements dot add, and then it says, you see, it asks us to add the web element. Now, in order to find this web element, we are going to use JS dot execute script. Okay, now we are going to use js.execute script. Now in that execute script, we would have to pass something like return, okay, and return, and then this one, document.query selector, this whole thing. So if if in JavaScript, if we simply say return document.query selector and this whole thing, it is going to return a web element to us, right? And that is exactly what we want. So we want to just return a web element. So now in order to access this value, we can simply say attribute dot get value, and that's it. Okay, so this is what we need to do. js.execute script, and the script that we're going to execute is return, um, and then concatenated by this value, this document.query selector. Okay, this JS path. That's it. But we have an error because we want to cast it to a web element. So this is what we need to do. That's it. That's the only thing that we need to add. We just need to add these lines. So if you don't want to write it yourself, you can simply copy it from the repository. I'm going to share the link of the gist that I have created for this for this addition, and you can simply add it in your automation object.java file, and then build a jar out of it. So I'm gonna build a jar out of this one. um, Select these two, export jar, next, make sure that these two are selected like always, and finish. Okay, so now that this is done, we are going to reload the tool or restart the tool. And that's it. So we go to our test case, and now we are good to execute this one. Okay, so we are going to run this in a debug mode. uh, so select Chrome, and I'm triggering the execution. I'm going to open up the console, and the first thing that we see is it has opened the URL. Now I'm going to move step by step. So the next step is highlighting some text. See, it has highlighted some text in this red rectangle with the message that element is highlighted. Bear in mind, this is also inside the shadow root, so it was able to identify it using JS path. Very good. The next one, nested text, that is also highlighted, also using JS path, and this is under two shadow roots, right? So a nested shadow root. So this is also very good. The scroll.html also highlighted, also under a shadow root. Very good. Then scroll.html, this is highlighted, but this was identified using XPath. So it also shows that whatever changes we made to the engine does not affect any other uh, identifying capability as well. And the final one is entering the text dummy in the text box, which is also identified via JavaScript or JS path, sorry. Right, so finally we end the test case, and so this is how we are able to handle shadow roots, shadow DOMs, by simply using JS path as an attribute, and then using the elements in the same exact way as you would use any other non-shadow root elements, and use the same actions that are available within the tool without writing any kind of a massive level of customization or looping and all that kind of stuff. The only addition that we did was just add these 4 or 5 lines into the engine, into the object finding class, And that was it. So I hope you liked this video. I see you all in the next video.